I'm in the process of repairing this Mimi 802. It's been sent to me for what should have been an electronic repair. Unfortunately, it's suffered some damage in transit. It's got a huge crack all the way through on this side. It's got another crack on this side, and it's cracked through at this point here. So 3 major breaks on the outside of the case. There are also some pieces that have been kind of ripped out on the inside. There's a piece missing at the front, but I can't find that. That may have been gone already before it was shipped, but that wasn't in the box. Can't find it anywhere, so I'm going to leave that. But I do want to repair these cracks. Now, if this was a museum piece, you would bond these together so that both the inside and the outside look fairly neat. But the owner of this is not mine. The owner of this wants to actually use this machine, so I need to make this strong enough to actually use, and also strong enough to be shipped back to the owner. So the way I go about repairing something like this, the first thing I've done, because this crack was fairly opened up and it was the entire case had kind of bowed out, this is thermosetting plastic, so you can't just reheat it and reform it. Once it's been set the first time, you can't remelt it. So what I normally do to try and stabilize the shape of the case, in this case I try to align everything, put some clamps on it, and I put it into an oven at 60 degrees centigrade overnight, and that does seem to have closed up some of the cracks. If this one in particular has closed right up, there was quite a big gap here, this had opened up, and also the one over here, there's kind of a big spiderweb crack over here, and that had opened up as well. This one I'm not too sure about. It has closed up, but with this type of brittle plastic, when it breaks, you quite often lose some material along the crack, and then when you put it back together, there's still a visible line because the inside material's a different colour. But we'll do what we can, get this bonded up, but to make it strong enough to use, rather than just bonding it, let's turn this over. What I'll be doing here is, you can see there's some material missing here. That's one of these pieces that I have found. I'll bond that back in. But what I'll be doing is machining some slots across here and putting in some carbon fibre rods and bonding those in. I'll do the same on both sides. There's a crack along the side. This is cracked all the way through this side and across here. Like I said, it has closed up when I heated it, but it still needs to be actually bonded together. And it's also cracked all the way down to this support for the keyboard. The keyboard screws were really tight, way over tightened. I don't know who put them in, but they do not need to be tight when putting screws into metal inserts in plastic cases. And it has ripped all the inserts out, they rotate, so I'll need to pull those out and bond those back in. These two as well have been over tightened at some point, and so I'll take those out, clean up the holes, bond those back in. The two that were attached to the chassis obviously got pulled out in shipping, so I'll bond those back in as well. And by the time I've done all this, carbon fibre rods, bonded it all in, given it a good clean, it should be a usable case. It won't be perfect, but it should be at least usable, and shouldn't look too terrible. So I'm going to begin by doing that, and once the case is sorted out, or at least while it's setting up, we can move on to the electronics and see what the original repair was supposed to be. So after several hours work, the case is now usable again. It's not perfect, you can still see the cracks, but if the owner wants to, what you can do is get some matching paint, and you can just wick it into the cracks. You can't feel the crack. You can only see it because there's always a small amount of material lost when you get a break in brittle plastic like this. But if you find a matching colour paint, just get a cocktail stick, dip it in the paint, just touch it onto the end of the crack, and it should wick the paint into the crack. As long as the colours are fairly close match, then it will tend to make the crack disappear entirely. So the case is now usable. It's actually stronger than it was originally, so it should be fine. I'll take this apart in a minute so we can see inside, but I've also straightened out the metal chassis, and it was fairly badly bent up, and the tabs on the end that they're supposed to mount it were badly bent. So I've strained it all out. It now fits properly. But there were only 2 of the 8 fasteners installed when it was shipped. Another reason why all this damage has occurred. One modification I'm making to this machine, it's not really a modification to the machine, it's kind of an addition, is the metal chassis. It kind of hangs at either end from the plastic. The screws go upwards, so this is just hanging there, and the 2 drives and the power supply are quite heavy, and if you push on the middle of this, it does flex and bow downwards. Over the years, when this gets banged down onto tables, that slowly bends and the 2 drives start to droop in the centre, and it looks a bit odd. And there's also the danger, of course, of it getting broken again. So I've made up this. It's made from solid Delrin. It's a very tough plastic. You could in theory 3D print these, but because it's got a very small cross-sectional area, it's not really a good idea to 3D print these. They probably just snap off. But what it's for, the PCB is screwed down into the base of the machine. It's a very thick, solid, strong base. And the PCB is held to these bosses with these 10mm screws, and there are about, I think, 6 screws that hold it in place, and there's one right in the centre of the board. So the idea of this is it sits and it's mounted on the centre one of these bosses. It's I say Delrin, it's got a taper at the end, and this sits on top of the PCB, so the taper's so that it doesn't press on the tracks that are around the hole. Longer screws, counterboard, so the screw goes through, so this now effectively replaces one of the original screws. That screws through the board into the boss, so it sits on one of the pillars, sort of like this, and it's the right height, so it sits just on the underside of the metal chassis, so it supports the centre of the metal chassis, stops it flexing down, and then most of the load and the weight of the metal chassis will actually go through this directly to the base. So if it does get dropped again, it's far less likely it's going to break anything. So I'll fit that. The owner can always take it out if they don't want it. I'll return the original screw, but that should make the entire thing much more resilient to being dropped. So I'll get this opened up, show you the other repairs that I've done, and we can then move on to the electronics. I haven't had to do anything to the base other than give it a good clean. This is the centre hole I was talking about, and that standoff, that pillar, let's get it again, will go through the PCB and sit in this location, and that sits underneath the metal chassis, transfers the load directly through to this. There were 3 of these 6 screws missing, and so I have made up a completely new set of screws for this. M4s, but a bit of an odd length, so I've made up a complete set of 6, and I'll just return the 3 screws that were sent back when I send the machine back. So that will allow us to screw the base on properly and give it far more support. So the other repairs I carried out, there were several breaks in this, as I said before, and I've machined across the cracks, the breaks, and then cut a piece of 3mm carbon fibre rod. That's the press fit into the slots, and then I've epoxied those in place. I pulled out all the metal inserts, most were loose, including the ones that hold the metal chassis in place, and epoxied those back in place. One of the inserts was missing completely, so I've machined a new one, epoxied that in place. So all the inserts are now properly attached, and they shouldn't pull back out. I will find a set of 4 screws. There should be 4 screws, one here, and the equivalent at the front, that help to hold this in place. So there should be 8 fasteners that hold this in place, and there were only 2 when it was sent. These must be in place, otherwise, again, this will just pull these out, and it may even break the case across this section, which is far harder to repair. So if you do take one of these apart, make sure you put all the screws back in, otherwise you'll end up damaging the machine. So this is now done. It's ready to refit the board to, so that's what we need to move on to next, is the electronics. So I'll get the first part of that onto the bench, which is of course the power supply. So here's the power supply out of this unit, and some work has been done on this, but really I need to rework this. A couple of capacitors have been fitted here, and as usual it looks like the original reefer cap has exploded. But these have been fitted in a bit of an odd way. I think someone was trying to avoid having to take the board off the chassis, so they've apparently cut the capacitor off and left the original leads poking through the board and soldered the new caps to those little stubs that are left, but that's not a good way of doing that. So I'll take these out, refit them, clean the board and get this carbon off it, and I'll also replace the other two caps while I'm at it. So that's the next thing to do. I'll get that done. I'll test all the larger caps, make sure there's nothing untoward. Incidentally, I think I've mentioned in previous videos that if you just plug these into the power supply, you apply mains to these two pins, but if you just connect mains with no load, you won't get any output. The supply will shut itself down. You do need to have a load on it before it will output a sensible power supply. So the first thing to do is to get this removed, get the caps changed. I'll, as I say, give it an inspection, and then we can connect it up to a load and see if it actually works. So I've removed the two caps that had been changed. I've taken the other two reefer caps out, and what I want to do now is clean up this mess. This stuff does conduct, and so I want to get this cleaned off, and then I'll put some fresh caps in there, and we can move on to testing it. So that's the board cleaned up. I haven't cleaned the entire board, just the areas that were burnt. So I can now refit the capacitors, get this put back into the chassis, and we can give it a test. I fitted new capacitors, I've refitted the board to the chassis. I did carry out the usual static checks looking for any shorted caps or open circuit caps or any shorted devices. Test fine, can't find anything wrong with it, and what I'm going to do now is try and power this up. Now, like I said, if you power this up with no load, it won't do anything. I will do that initially just to make sure that it doesn't go bang or anything terrible happens straight away, and then I'm going to use the actual main PCB as the load. I know this has been turned on already, so if it's damaged, then we shouldn't do anything any more damage to it. So I'll get this hooked up, and we can then test the supplies and see what we're getting out of this. I suspect it will work. These do tend to be fairly reliable, and normally if there is a fault with them, you can detect it fairly easily with a multimeter, but this one does seem as if though it should work. So we'll get this hooked up and see what happens. So as you can see, I've got the power supply hooked up to the main board. I haven't bothered reconnecting the disk drives at this point. The main board will be easily enough load for the power supply to work if it's capable of outputting any voltage. I have already taken out the ROM and tried to read it. It did seem to read okay, so hopefully that's intact. Although the title of this video says it's a MIMI 802, as you can probably tell from the board, this is an 801 board, so should be fairly interesting to try and get this working. So we're all hooked up, got the mains connected through the rear panel using the bench mains supply. Got the multimeter on standby. Put this hopefully somewhere where you can see it. And so what I'm going to do is power up the supply. Now I did power it up off camera with no load connected, and got the usual ticking noise from the supply. What it does, it tries to ramp up the voltage, and when there's no load, it overshoots, shuts down, and it keeps repeating that. Don't leave it like that for too long though, because you will damage it. Okay, so we're now hooked up, and we'll try and measure a few voltages on the main board. We should be able to detect 5 volts and 12 volts, but we'll see what we find. So I'll power this up, fingers crossed. The fan on the rear panel is turning. and we're drawing a reasonable current. So let's try taking a few measurements off the board. So we'll try this one, and we should get around 5 volts. 4.956, very good. So we'll try a few other places. Now what I've noticed already is a lot of these ICs are not plugged all the way in, so I suspect we may have an issue with some of these. 4.8, that's fine. Try a few more. 4.9, that's fine. Just checking that is a TTL component. Okay, that doesn't look right, so something strange going on there somewhere. Let's try. Okay, very odd. So we're getting, this just might be a problem with the socket on that particular device, but let's try 12 volt supply. 11.7, I've got it connected backwards, so it is going to say minus 11.7, but 11.7 volts, that's fine. These are in parallel, so this should be the same. 11.7. Okay, good. Well, it looks like the power supply is working. We're getting 5 volts on some devices, not all, so I think we do have an issue somewhere. As I say, it might just be that some of these sockets aren't making good contact. They are a type of socket that unfortunately does tend to be a bit notorious for not making good contact. What I'm going to do now is, it's been on for, well, you've seen it, about 3 minutes. So got the thermal camera, we'll have a quick look around this. Okay, and straight away we've got an issue here where looks like the system's not running correctly. We're getting one bank of RAM chips all through the camera. It looks like they're very hot. It's quite deceptive. The small differences in temperature can make it look like they're burning up, but what we've got is just 2 rows of these are showing up as fairly hot. So it might be that it's just those 2 rows that are being accessed, or it could mean that they are permanently enabled because the system's not running. Have a look around, get a few other hot spots. The large scale devices will tend to show up as fairly hot, but nothing is getting particularly hot. That one's a bit too cold, if anything. So it's looking like it's not doing anything. But nothing getting ridiculously hot. Just a usual span in temperatures. The only thing that looks a bit odd is firstly the RAM chips do seem to be getting a lot warmer relative to each other than I would expect, and then that's normally because the system isn't running. These are enabled permanently and it does tend to make them fairly hot. So I'm going to turn this off now, I don't want to damage them. So if the system isn't running and these are selected, then they do tend to heat up fairly quickly. They're actually getting fairly warm, a lot warmer than I would normally expect, but because they're all getting fairly warm, I suspect it's because they're permanently enabled. Okay, so in the next video what we'll do is we'll start fault finding. We've got the case sorted out, as far as I'm going to sort it out. We've got the power supply, it seems to be working fine. I will check it for ripple and load off camera. I won't do that on camera, you've seen that before, and it is quite tedious to watch. And assuming that works fine, then in the next video we'll move on to the main board, get a scope onto this and try and figure out if it's running at all, and then go from there, try and get it working.